So tonight we're going to talk about probably the last of the major project management lectures. We'll be talking about risk management and then change control. And then we'll go over the pre-PDR and PDR document templates, just to give you an idea about what our expectation is on these things. So risk management is important. It's an important aspect. It is obvious that there are going to be chance events that will affect your project. This picture here is the picture of Lawn Chair Larry. You can look it up on Google as to what it is and what happened to him. He's one of the few people who actually got a honorable mention Darwin Award. He decided he wanted to go up and do some ballooning, so he took literally a lawn chair and tied a bunch of helium balloons to it, and he thought he had everything under control. He had a BB gun so that he could shoot and pop some of the balloons and so come on down, and he brought a couple sandwiches and some water and that sort of thing. Well, he didn't quite plan all of his risks appropriately, because when he took off, there was such a jolt that his BB gun fell off, as well as his lunch and water. So he went up to, I don't know, 1,000 feet, something like that. And he had no way of getting down. And he almost, this was in sort of the Los Angeles type area. And eventually police helicopters came and shot some of the balloons. But when he landed, he was like on the edge of the Pacific Ocean. If he would have drifted over to the Pacific Ocean, he would have been dead. So hence the honorable mention. And hence also the need to look at your risks and be able to manage those risks. All projects are subject to Murphy's Laws. If you don't know what Murphy's Laws are, then Google it, and you will come up with a whole plethora of them. The basic Murphy Law is, if anything can go wrong, it will. And a corollary of that is, of the things that could go wrong, the one that causes the most damage will occur. And there's a whole plethora other numbers of Murphy's Laws as well. So the official definition of project risks is a undesirable event, the chance this event might occur, and the consequences of all possible outcomes. Notice that there's three parts to a risk. Risk management that you would be doing during your project attempts to try to identify some events and minimize their impact on the project. And if such an event occurs, then provide a response. The essence of project management is risk management. So this is a very important thing to pay attention to. So the risk that happens during projects is associated with cost. So early in a project life cycle, as is shown in this plot here, there is a pretty high probability of various kinds of risks occurring, but the impact to the project is relatively low. As you proceed through your project, that risk probability goes down, but the impact for any particular risk goes way, way, way up. So being able to identify and manage those risks and have a management process in place early on is important for helping your project succeed. There's particular steps that you do when trying to develop your risk management plan. There's four major steps. First of all, identify all the possible risk events that can affect the project. Then assess each risk in terms of probability, severity, and controllability. Next, develop a strategy or a contingency for responding to each risk. And then finally, monitor how those risks are, whether or not any of the events are occurring, and control them if they are detected. So that's a loop, and the figure sort of shows this process as it goes. The risk management plan that you're going to put in place in your document should be developed initially. You should have a preliminary one in your PDR, and you should be updating it and revising it as you go through your project. So how do you identify your project risk? Well, first of all, you basically sit down as a team and you start brainstorming all the possible risks that can happen, all the way from a cold solder joint to accidentally dropping the payload and breaking everything, to whatever other kinds of risks that you can think of. You just basically brainstorm. You don't assess the probability. All that you're trying to do at this point is just to identify all the possible project risks there are. You get probability and consequences, a little bit later. Focus on the event itself, not the consequences. So the example here, instrument does not return correct data. That is not a risk event. That is a consequence of something like a cold solder joint or a bad or failed software routine or something like that. So you want to identify the risk event, not the consequence at this stage. Focus first on the overall project risk and then identify specific risks. So what you're doing is that you're looking at things like risk to your schedule, to the payload in general, and then you'd start focusing more on things like specific components, like your sensors or your electronic boards or your control software or ground software. Use your WBS. Did I mention previously that putting together a WBS is important in a project? So you can use the WBS here to help you identify some of these risks and organize your thought process about the risks. Look for input from outside your group. I'm certain that your faculty advisor is going to be well versed in the kinds of risks that could possibly happen during your project. Make certain that you remember that Murphy's laws exist and keep that in mind when you are coming through and brainstorming your events. Do critical thinking, emphasize critical thinking. All right, after you sort of get the list of all the possible risks that you possibly have, now you want to start putting together like a scenario analysis. So for each risk, you want to determine the consequences and the severity if that event happens, identify when during the project that the event is likely to happen, estimate the probability that the risk event will occur, and also determine how difficult it would be to detect the event. So those are all important pieces in order to try to understand how important a risk is, or whether or not you really need to even consider it later in your plan. Once you get that core information, then you want to sort of rank the risks. And one of the best ways to do that is what's called a risk severity matrix. You should probably put such a matrix in your document when you get it completed. So that the risk severity matrix puts it's a plot of event probability versus impact. So on the Y scale is the likelihood that such an event would occur from 1 to 5. So 1 being the lowest probability, 5 being the highest likelihood. And then on the x-axis is the impact, also from 1 to 5. And again, impact 1 is low impact, 5 is really bad. Okay, and so the red zone, which would have higher likelihood and major impact, those are the most important events that you need to pay attention to. Yellow zone are events that you probably are important, but not as critical as the red. And then green zone is probably events that you don't have to really worry about. Notice that these zones are not symmetrical. And that's because a low impact event is not as important, even if it is highly likely, that's not as important as a low likelihood, but severe impact risk. All right, so that's why these blocks are not symmetric. You need to keep that in mind. Okay. So how do you deal with risks when you identify them and rank them in terms of severity? Well, there's four major ways of doing it. Mitigating, which is something that you probably have heard, and that's basically some sort of action that you would take to either reduce the likelihood of a risk or reduce the impact. So examples of a mitigating is testing your electrical components after they come in. So you're going to order parts, and there is a risk that some of these parts may be out of spec or non-functional. And so a way to mitigate that is to test all the individual parts and reduce and basically eliminate the bad parts. Okay. Retaining a risk. So this is usually done for events that are high impact, but you don't really have a strategy for. So, a nuclear explosion occurs in the middle of your launch area. Okay. Well, I think you'd all agree that's a pretty high impact event, and also you got no control over it. All right, and it's probably not really all that likely either. So you would probably just retain that risk. You wouldn't try to figure out a contingency, what kind of bunkers you would make, or whatever that what you might come up with. You would just retain that risk, okay, and hope that it doesn't occur. Sharing risk. So suppose that you have some sets of risks that would be appropriate to share across different aspects of your payload. So that would be things that you would have a portion of that risk shared by different entities. And then finally, there's things like transferring risk. That this is something that student teams are very in favor of doing, because it says that the risk that you identify is basically assumed by some entity outside of your team or your immediate project. So, for example, all the risks associated with the balloon vehicle are transferred to us, to the LACES project team. So a risk is that there is a balloon burst premature, and those do occur. All right. But again, that's sort of nothing that you have control over. And that's sort of our risk that we do. And the way we handle that is that we have multiple balloons that we bring with us. So hopefully we could, depending upon when that balloon bursts, we can recover and presumably refly. So those are the primary ways of dealing with response. So once you identify those kinds of things, then you come up with a response plan, a risk response plan. And there's in this the figure here sort of shows the table that would be discussing here. So what kind of strategy would you be doing? Mitigation, reducing, transferring, how the risk event would be detected, right? And what plan would be put into place? What is the trigger? And most importantly, who is going to be responsible for monitoring and controlling that risk? Right? Anything you do with risk management, there has to be a person who is responsible for dealing with the risk, for identifying if that event has occurred, and then dealing with the response. Contingency. Remember the other time when we talked about scheduling, you don't pad your schedule. You don't take extra things into your schedule. You calculate your schedule for normal normal time and normal things. Contingencies is what you build into your schedules to handle risk, right? So you can handle other kinds of contingencies, like for example, in the technical aspects of your project by building and testing prototypes. That's why we emphasize after the PDR and you go into development, we emphasize that you basically build and test a prototype of your electronic interfacing or your software. You're not building flight hardware or software after PDR and before CDR. You're testing prototypes. And that's done in order to mitigate risks for your technical design, right? You may need to trade off different things. So if you're not making your schedule, or a team member has to drop out, and so there's more work that can be done, you might have to trade off performance. You might have to reduce or de-scope your payload in order to make that. Many times, risks associated with costs, like in time or money, are usually from errors in estimating or omissions in estimating. That's why when I talked about WBSs and the ways to figure out your schedule, those processes that I talked about the other day are designed to try to mitigate some of these risks in your schedule. All of your budgets, all right, all of the budgets that you do, your mass budget, your power budget, your schedule budget, your cost budget, they should always include a reserve percentage that can be used once you expand risk. So for example, you are limited, your payload is limited to 500 grams, right? And so if you exceed that, you don't fly. If you are 501 grams when you get measured on the flight line, you don't fly. So you need to put in a reserve in your mass budget, say a 20%. So something like, 100 grams, you put in reserve. And as you develop your payload and your mechanical and your electronics and that sort of thing, you can expend some of that 100 grams to make certain that you go underneath your 500 grams, right? Risk response process control. So you'll need to write up a risk management plan. That plan specifies your risks, your responses, and your mechanisms used to control the process. You need to be continuously monitoring for triggers, risk triggers, right? You need to identify these early in the projects, and monitoring for such events should occur like now, as soon as you get going in your PDR. Each risk should be assigned to a specific person who has the authority to identify and affect the response to that event. Changes in any, and we're going through configuration changes in a bit. So changes in any aspect of the project need to be documented and communicated. Who will have the authority to approve the change? Make certain that you write everything down. If it's not written down, it didn't happen. You can get into troubles if you don't write things down. And then who is going to be notified of what changes and when that change occurs.